Hello, let's take a look at some of the more challenging questions from the 2020 paper higher. So I'm going to look at the paper one first of all, some of the more interesting questions. And paper one is the non-calculator paper. And I'm going to start by diving in at question 13. So we've got two liquids, A and B, are mixed to make another liquid C. And so this is a density question. So let's start by writing down density is mass over volume. And then for the first one, we get given, so for liquid A, we are given the density and the mass. The density and the mass. So the volume equals the mass divided by the density if we rearrange. So the mass is 1400. The density is 70. And we can simplify that. 7 into 140 go 20 times. So we've got the volume for A. So for B, liquid B, we've got liquid B, we've got the density and the volume. So this time we need to rearrange for the mass equals the density times the volume. So the mass equals the density, which is 280, times the volume, which is 30. So we need to do 3 times 280, or 30 times 280, which is 84, and then there's 2 zeros. So that's the mass of B. So for C, we've got density. It says work out the density of liquid C. So the density equals the mass over the volume again. Now, all we need to do is make sure we add up our masses and our volumes. So the masses must be combined mass of the two. So for A, the mass is 1400. And for B, it's 8400. And we need to divide by the total volume. Well, the volume for B is 30 and for A is 20. So it's 20 plus 30. So 84, 94, 98, 9800 divided by 50. Zeros cancel. Let's just put this down here. 980. 5s into 9 go once with 4 left over. 5 9s 45. So that's 9. And that leaves 3. 5s into 30 goes 6 times. So the answer is 196 kilograms per meter cubed. Question is that reasonable? Well, what have we got? The separate densities. We've got density of 70 for one and 280 for the other. So it shouldn't be a surprise that C lies somewhere in between those two densities. And we're done.